Hi everyone, welcome back. So in this video we're going to start the new unit. We're going to start my favorite unit, or favorite concept rather. We're going to start diving into trig. So just to start off, before we even dive into really kind of the meat of what we're getting to, we're going to do a quick recap of rationalizing. So with rationalizing, what's happening is we're eliminating a radical in the denominator, because when you're writing your answers in simplest form, having a radical in the denominator is the equivalent of not simplifying fractions or leaving negative exponents or anything like that. It's just part of the rules that we just have to abide by. So, looking at this very first one, we have 5 divided by the square root of 2. What I want to do to rationalize is I'm going to look at my radical value that's in the denominator, and we're going to multiply by what we call a funky form of 1. So, in order to get rid of that root 2 in the bottom, I'm going to multiply by root 2 over root 2. So if I were to simplify this fraction right here, we're multiplying by a value of 1. So I'm not changing the value, I'm changing the form. Like when you freeze water, you get ice. You're changing the state of matter, you're not changing the molecular makeup. So kind of the same idea here, we're just changing the way it looks. So when I rationalize by multiplying by root 2 over root 2, then with your fractions, you're going to multiply across numerator to numerator, denominator to denominator. So in the numerator, we're going to be left with 5 root 2. And then in the denominator, we're going to have root 2 times root 2, which I'm going to combine those into a single radical. So that's going to be the same as 5 root 2 over the square root of 4. And we know the square root of 4 to just be 2. So this would be 5 root 2 over 2. So this would be your simplified form. So I kind of took the scenic route when I was simplifying this, but I'm going to show you a couple other ways. So same idea over here on number 2. So I'm going to reference whatever radical value I have in the denominator. So I'm going to multiply by root 3 over root 3. So when I multiply across, so we're going to have 3 root 3. And then when I look at the denominator, so root 3 times root 3 is root 9, which is going to give you 3. So then, when I look at my fraction even further, the 3 over 3, these are going to simplify. So all we're going to have left is root 3. So moral of the story is, when you have a radical, if I have root 2 times root 2, you're just going to get 2. If I have root 3 times root 3, you're just going to get 3. If I have the square root of n times the square root of n, you're going to get n. So if you're multiplying a radical value times a radical value of itself, you're just going to get that number. The radical is just going to go away. And in short, that's because of exponent properties. I don't want to take up too much time and explain that further, but I'll probably do that later. So looking at number 3, we're just going to practice this because knowing how to rationalize is going to be very important as we move forward. So you're always going to reference the number that's in the denominator that has the radical. So in this case, we have root 2 in the bottom, so I'm going to rationalize by multiplying by root 2 over root 2. The radical in the numerator, it doesn't matter. We can have a radical in the numerator, and that's totally fine. It's the radical in the denominator that we cannot have. So in the numerator, I'm going to combine the radical values, so we're going to have 2 times root 3 times root 2, which I'm going to combine, and that's going to become 2 root 6. And that's going to be over 2. And then simplify, and you get root 6. Okay, and then same idea on this last one. Once again, you're going to reference the denominator value, so I'm going to multiply by root 5 over root 5. So this is going to give you 2 root 30 over 3 times 5, which this is going to simplify and become 2 root 30 over 15. And then 3 over 15 can simplify, and that's just going to become root 30 over 5. Now, typically, if you can, you would also simplify your radical. So meaning I'm going to do the prime factorization of 30, and we're going to look for pairs. You can do the factor tree, or you can do it all inside the radical. It's really up to you. So if I do square root of 30, that's going to be equal to the square root, I cannot draw today, the square root of 5 times 6, and then 6 can break down into 2 and 3. So it doesn't break down anymore, which means it doesn't simplify, but if it does break down and simplify further, you are going to be expected to simplify those radicals as well. So your final answer would just be root 30 over 5. Okay, so that's kind of a quick recap of rationalizing. Now we're going to get into trig ratios. So this information at the top, I'm going to come back to this in a bit, but we're just going to kind of dive into these trig ratios. So this should be a recap from geometry. This should not be anything new. So looking at your trig ratios, you may have heard of the mnemonic SOHCAHTOA. If you use SOHCAHTOA, I'm not saying it's bad or any means. I'm just saying you want to kind of lean away from using mnemonics, because in Precal, especially AP Precal, you need to know the ratios just right off the top of your head. You don't want to think about the mnemonic and then go to the ratios. You want to go straight to the ratio. You need to know these ratios very well. So speaking of, looking at these ratios, these are going to pertain specifically to right triangles. So when we're looking at right triangles, we're going to have sine of theta, which is going to be the opposite over the hypotenuse of that triangle. And then we have cosine theta, which is the adjacent over the hypotenuse. And then we're going to have tangent theta, which is opposite over the adjacent. Now, keep in mind, these are only for right triangles. If it's not in right triangles, what's going to happen is you're going to look at what we call the law of sine and the law of cosine. So I will say in AP Precal, we don't cover those concepts, but I do think those are very important concepts. So for anyone venturing into calculus or higher level mathematics at any point, I do recommend that you go and do a quick learn about those concepts. I do have videos of those. All right, so looking at these trig ratios, now we're going to get into some more important notation. So we're going to be doing what we call solving these right triangles. So when I say solving these triangles, it means we're going to be finding all the missing sides and angles. So we're going to give you 3 of the 6 attributes. So we're going to give you a combination of sides and angles, and then using trig ratios, you're going to be expected to solve the rest. So starting off, we're looking at what we call lowercase letters. Well, hopefully you know what those are. So lowercase letters in trig, these are going to represent your sides, whereas your uppercase letter, or capital letters, are going to represent your angles. So, looking at this first example over here, so you're going to use the trig ratios to evaluate the specific trig. Nope. You're going to use the triangle over here that we have labeled somewhat, and then using that triangle, we're going to find the specific trig ratios. So, over here, we give you triangle ABC, and we give you that little a is 3, so this would be 3, and that little c is 5. So those are lowercase letters, so those are going to represent your sides. So we give you 2 sides, and then we give you 1 angle. Now the 1 angle that we give you is going to be this right angle down here, because the trig ratios that we're doing, these have to be in right triangles. So if I want to find the missing side length down here, if I want to find side B, think back to your middle school days. We're going to do Pythagorean theorem. So in this case, this is just a 3, 4, 5 triangle, so I'm just going to kind of skip ahead and just write in the 4. But as a quick recap, your Pythagorean theorem is going to be a squared plus b squared equals c squared. And you will be expected to be able to solve these types of equations without a calculator. And you may be expected to deal with radicals, and you may have to rationalize as well. But in AP Precal, you will be expected to solve these by hand. So now we're going to jump into the actual trig ratios. So notice how in these trig ratios, we're using a specific letter. So I'm using the 3 big ratios in regards to angle A, but then we're also going to find the 3 big trig ratios in regards to angle B. So with sine of A, we're going to do the opposite of angle A over the hypotenuse of that triangle. So when I'm referencing angle A over here, you want to be able to interpret and know what exactly does it mean to be opposite and what it means to be adjacent. So when I say opposite, I'm saying what is going to subtend that angle. So that means side A, this is going to be opposite. And then the side length that is right next to that angle, that's not the hypotenuse, that means side B, this is going to be your adjacent. And then side C, it's across from your right angle, it subtends, which means this is going to be your hypotenuse. So when I write in my trig ratios using angle A, if I'm looking at sine, this is going to be the opposite over the hypotenuse. So opposite would be side A, which is 3, over the hypotenuse, which is 5. So over here, sine of A is going to be equivalent to 3 over 5. And then if I look at cosine of A, I want the adjacent over the hypotenuse, which means I want 4 over 5. And then if I want tangent, I want the opposite over the adjacent. So opposite, which is going to be 3, over the adjacent, which is 4. So then tangent of A is going to give me 3/4. Now, side note, yes, I know we only use the 3 letters to write out sine, cosine, and tangent, but you still are going to say sine, cosine, and tangent. You're going to say the full word, even though the actual word is abbreviated. If you saying sin is a sin. If you say cos, it's still a sin. If you're saying tan, well, you're not out in the sun, that's also going to be a sin. So you're still going to say the full word. Anytime you say those naughty words, it just hurts a mathematician. All right, so now looking over at B, so angle B over here. So I'm going to get rid of what we just did for angle A, and we're going to look at this triangle from a different lens. So now I'm going to focus on my perspective from angle B. So with angle B, now opposite of angle B is going to be side B. So what this tells me is this is now going to be the opposite, and then side A is now going to be the adjacent, and then side C, well, that's still your hypotenuse. It's still across from your right angle. So notice how when we switch angles, your opposite and adjacent are also going to switch. Your hypotenuse is going to stay the same. So when I'm looking at sine of B, I want the opposite over the adjacent. So I want 4 over 3. And then if I want cosine of B, so I want the adjacent over the hypotenuse. So the adjacent, which is going to be 3, over the hypotenuse, which is 5. So 3/5. And then I want tangent B. So that's going to be your opposite over adjacent, which is going to be 4/3. Okay, so hopefully that's a really good recap of your geometry trig ratios that you did before. I'm just going to do 2 of these problems. This is also kind of a recap of your geometry days. So you're going to find the missing sides and angles of each triangle using the trig ratios. Now, it doesn't specify which trig ratios you have to use. That's going to be contingent on what information is given and how you set up your ratios. So with number 2, so I'm going to do all my given information in orange. So I know big A is 26. Now your capital letters are going to represent your angles. So over here, big A is going to be 26 degrees. And then they also give me little c, which is 14. So that's going to be your hypotenuse because that's across from your right angle. So then I get all the time, well, what do you mean they give you 3? I only have 2 values that are given. Well, remember, we work in a right triangle. So angle C, in this case, with how it's labeled, is going to be the 3rd value that they give you. So I'm going to come down here in my chart. So I'm going to write in the given information first. So 26 degrees. And then we also know big C, which is 90 degrees. And then I know little c, which is 14. Okay, now before I move on, I'm actually going to reference what I have at the very top of the screen, because this is some really important information. So ideally I would have done this on paper, but it's okay. So I just wrote down the calculator steps. So when you're doing these values on your calculator, you have to make sure that you're in the correct mode. So in order to get in the correct mode on your calculator, especially, well, this is really for Casio's, you need to be on the Run Matrix menu or the Run Matrix program, and then you're going to press Shift, Menu, and then that's going to take you to the setup screen. And then you need to scroll down to where it says angle, and you need to change your mode to degree mode. By default, it's going to be on radian mode, but we need to be in degree mode for these problems. So we're actually going to be talking about radians in the next lesson. So for right now, we're going to stay in degree mode, but just by default, just know that you're going to be in degree mode. Or no, by default, you're going to be in radian mode, but we need to be in degree mode. So I will say, if you're solving these problems and then you're getting some really funky numbers, well, that's probably going to be your face. probably wondering why the heck does my calculator tell me these weird values. That's going to be an indicator that you're in the wrong mode. Okay, so down here, starting off, so I have 2 of my 3 angles, so the first thing I'm going to find is going to be angle B. So there are 180 degrees in a triangle, so in order to find angle B, I'm going to do 180 minus 90 degrees minus 26 degrees, and then when you subtract, you're going to get angle B is going to be equal to 64 degrees. So I'm going to put that in my chart, so 64 degrees. Okay, now I need to find little a, which is going to be across from angle A, and then I also need to find side B, which is going to be across from angle B. So if I want to find side A, what I always tell people is stick with your given information. If you use a calculated value versus a given value, you're running the risk of using a wrong value to get another wrong value. So I recommend only using the values that are here in orange. That way you're not using a calculated value. But that's just me. Not saying you can't use a calculated value, I just strongly recommend against it if possible. So if I want to find side A, I know I have 26 degrees over here, and I know side A is opposite of it, and I'm also given the hypotenuse. So think of a ratio that uses the opposite and the hypotenuse. So that tells me I want to use my sine ratio. So my setup here, I'm going to do sine of the angle, which is going to be 26 degrees, and that's going to equal the opposite, which is my A value, over the hypotenuse, which is 14. And we're going to solve this equation for my A value. So I'm going to multiply both sides by 14. So my A value is going to equal 14 times sine of 26. So this is where you're going to go to your calculator because that's the exact form, but we want the approximate form. So I'm going to do 14 times sine 26, and then that's going to give us approximately, because I'm going to round to 3 decimal places, 6.137. So 6.137. All right, now I'm ready to find side B. So side B, I'm going to reference the given information again. So angle 26 is adjacent to side B, and then I also have the hypotenuse. So adjacent and hypotenuse tells me I'm going to use cosine. So I want cosine of 26, and then that's going to equal B over 14, so the adjacent of the hypotenuse, multiply both sides by 14. So B is going to equal 14 times cosine 26. So when you type in, so 14 cosine 26, that's going to give you 12.583. Okay, so there's this one. So 7 is going to work very similar. I know on 7 I use tangent ratios, so just another example for you. But we're going to scroll down and we're going to look at number 8. So number 8 here, same idea, but now notice how we're given side lengths. So when you're given side lengths and you're not given angles, that's going to be indicative that you're going to have to actually use inverse trig. So I'm going to start by labeling. So I know side C, which is our hypotenuse, is going to be 109. And then if I have side B, that's going to be 91. So side B, that's going to be opposite of angle B. So this is 91. And then, of course, we have our 90-degree angle, which is going to be given. So big C is going to be 90. Little c is 109. And then little b is 91. All right, so first thing I notice that I can do is I am going to go ahead and find that missing side. So I can find side A. Now, if I have 2 of the 3 sides, I'm going to use Pythagorean theorem. So I have a squared plus b squared is going to be equal to c squared. So I'm solving for my a value. So we're going to have a squared plus 91 squared is going to be equal to 109 squared. So I'm going to subtract the 91 squared on both sides. So a squared is going to be equal to 109 squared minus 91 squared. And then I want to take the square root. Now we can't have a negative length, so we're only going to deal with a positive value. So square root of 109 squared minus 91 squared. And then when you do this value, so this is going to give you 60. So I know little a is going to be 60. So I'm going to go ahead and mark this over here, which you can, you don't have to. All right, now for the next part, I'm going to go ahead and find angle A. So with angle A, I am given the adjacent, and I also have the hypotenuse. So if I have the adjacent and hypotenuse, I'm going to use a cosine ratio. So I'm going to have cosine of some unknown angle A, and that's going to equal the adjacent over the hypotenuse. So I want to figure out what this A value is. So what I need to do in terms of equations is I need to get rid of this cosine. So what I'm going to do is I'm actually going to take the inverse cosine of both sides. So what this is going to look like, make sure I give myself plenty of room. So I want to take inverse cosine of both sides. Now when you take the inverse cosine, on the left side, the cosine and the inverse cosine are going to simplify. So we're going to be left with A equals inverse cosine of 91 over 109. So now that you have your A value isolated, now I'm ready to actually go to my calculator and type it in. So this is going to be the exact form. I want the approximate form. So when I have to type in, so I want inverse cosine. So on the Casio, to get the inverse, you're going to press shift cosine. So shift cosine, and that's going to be 91 over 109. And that's going to give you an angle value of 33.398 degrees. Okay, now we still need to find angle B. Now, I will say you're going to have a couple options on how you can solve for angle B. So I'll move this up a little bit. So with angle B, you technically can use, hold on, let me fix this label. There we go. So with angle B, because we now have two angles, you can use, or you can find B using a calculated value if you want to, or you can just use the given values and you can work backwards like what we just did. So I'm actually going to use the given values first, and then I'm going to show you what it looks like using a calculated value. So with angle B, so I have the opposite side length, and I have the hypotenuse. So opposite and hypotenuse means I'm going to use inverse sine. So I'm going to have sine of B, and that's going to be 91 over 109. Now, same instance as before, I'm going to take inverse sine of both sides. So that's going to be B is equal to inverse sine of 91 over 109. So when you plug in, so B is going to be equal to 56.602 degrees. Okay, now that's using the actual value. Now, if you want to use the calculated value of A, another option is going to be if you do 180 minus 90 and then minus angle A. Now, angle A, we did say over here that it's going to be inverse cosine of 91 over 109. So if you want to plug this in your calculator, you'll get the same thing. You will get 56.602 degrees. So it's really up to you on how you want to approach it, how you want to solve it. I will leave it up to you. You get the same thing either way, hopefully. Fingers crossed. All right, so moving on. Now we're going to get into some of the new parts. So the new parts is what we're going to be using to kind of push trig ratios even further along. So the first ones we're going to look at is what we call the reciprocal trigonometric ratios. Now, I will say this is going to be very important when we start trig identities, which that is my favorite unit. So trig the trig reciprocal ratios here is we're going to be doing 1 over sine, and then that's going to give you another trig ratio. So in this case, cosecant, actually probably I should have left these blank and then we'll go through these. That's okay. All right, so cosecant here is actually going to be 1 over sine of theta. Now your sine value, or your sine ratio, of course, is going to represent the opposite over the hypotenuse. So when I simplify, I'm going to multiply by the reciprocal. So this is actually going to be equivalent to the hypotenuse over the opposite, which is where your ratio comes from. And then same idea for secant. So secant is 1 over cosine theta, which cosine theta is going to be 1 over the adjacent over the hypotenuse. And then same idea, if I multiply by the reciprocal, that's going to represent your hypotenuse over your adjacent, which of course, that's where your secant ratio comes from. And then same idea for cotangent. It's going to be 1 over tangent theta, where tangent theta is going to be your opposite over your adjacent. So when you multiply by the reciprocal, you're going to get the adjacent over the opposite. So that's where your reciprocal trig ratios are going to come from. So we're going to look at the same figure, but now we're going to do the reciprocal trig ratios. So based on my image here, it's the same image. I know that A is 3. The Pythagorean triple makes B value 4, and then little c up here is going to be 5. So if I'm looking at cosecant of A tells me I want the hypotenuse over the opposite. So I want the hypotenuse, which is over the opposite, so that's going to be 5 over 3. Okay, and then secant is going to be the opposite over the adjacent. So, nope, the hypotenuse over the adjacent. So I want 5 over 4. Okay, and then cotangent, I want the adjacent over the opposite. So that would be 4 over 3. And now we're going to do the same idea, but now in terms of angle B. So I would say I'll pause here, or you pause here, and you actually try angle B. So with angle B, now we're looking at cosecant of B. So cosecant tells me I want the hypotenuse over the opposite. So opposite of B is going to be side B. So if I want the hypotenuse over the opposite, I want 5 over 4. Then if I want secant, that's going to be the opposite over the adjacent. Nope, no it's not. Hypotenuse over the adjacent, which is going to be 5 over 3. And then if I want cotangent, that's going to be the adjacent over the opposite, which in this case is going to be 3 over 4. Okay, so I should have mentioned this before, but also one thing to point out and notice is notice how these values switch. And then for your cotangent, they just flip. So that's a nice little feature to also kind of keep in mind. So it happens up here as well. So with your sine and cosine, when you switch the angles, they switch, and then your tangent value flips. All right, so now, given secant of A is equal to 13 over 12, you're going to find the other trig ratios. So what's going to happen here is you may have to do some Pythagorean theorem to find out what the ratios are. So I know that if I'm working with secant of A, secant is going to be the hypotenuse, and then that's going to be over the adjacent. So in regards to A, so I know 13 is going to be the hypotenuse, and then adjacent to A is going to be 12. So based on Pythagorean theorem, I know this is a Pythagorean triple, so that tells me that this is going to be 5. So if you need to do Pythagorean theorem, a squared plus b squared equals c squared. So that would be a squared plus 12 squared equals 13 squared. So that's going to be the square root of 13 squared minus 12 squared, which is going to give you the square root of 25, which is going to give you 5. So there's Pythagorean theorem if you need it. So now I'm ready to do my trig ratios. Now keep in mind we're doing the 6 trig ratios, but all these values are going to be in regards to angle A. So if I'm looking at sine of A, so I want the opposite over the hypotenuse, so that's going to be 5 over 13. Math is hard. And then cosine, that's going to be the adjacent over the hypotenuse, which is going to be, 12 over 13. And then tangent's going to be the opposite over the adjacent, so that's going to be 5 over 12. And then when you do the reciprocal trig ratios, what's nice about these is you can just take your trig ratios over here that you have, and you're just going to take the reciprocal of them, hence why they're reciprocal trig ratios. So cosecant of A is just going to be 13 over 5. Secant of A is going to be 13 over 12. And then cotangent of A is going to be 12 over 5. So we're just taking the reciprocal of the existing trig ratios that we have. So let's go ahead and do number 8. So if cotangent of B is equal to 2/3, you want to find the other trig ratios. So cotangent is going to be the adjacent over the opposite. So of B, so I'm looking at this angle up here, so the adjacent would be the vertical leg, and then the opposite would be the horizontal leg, which is 3. And then you need to do Pythagorean theorem to find the hypotenuse. Okay, so with this one, so 2 squared plus 3 squared is going to equal c squared. So this is going to be 4 plus 9 is going to equal c squared. So c is going to equal the square root of 13, which that doesn't simplify, so you're just going to leave it as square root of 13. Okay, so now I'm ready to do my trig ratios. So if I want sine of B, so remember, we're looking in regards to B up here. So this would be the opposite over here. So your opposite is going to be 3 over root 13. And then here's the reason why I'm doing this one, because we have a naughty number down here. We can't have radicals in the denominator, so I need to rationalize. So I'm going to multiply by root 13 over root 13. So once you rationalize, so 3 root 13 over 13, and I'm good to go. So now cosine, so that's going to be 2 over root 13. So once again, I need to rationalize, so multiply by root 13 over root 13. So this is going to give you 2 root 13 over 13, and I don't need to simplify any further. We're good to go. Tangent of B is going to be the opposite over the adjacent, so that's going to be 3/2. And then when you do your reciprocal trig ratios, you can just flip them. Now, when you're flipping, you can either use and reference the original, or you can reference the simplified. So in this case, if I were to flip the simplified, that's going to put a radical in the denominator, which I want to avoid. So I'm going to reference just the original. So when I reference the original, I'm going to flip it, and we get root 13 over 3. Same with secant of B. I can either flip the original or the simplified. Well, if I flip the simplified, we have another radical, so I'm going to avoid that one. I'm going to use the original. So that's going to be root 13 over 2. And then cotangent B, which they give you, but if you flip it, or if you flip tangent, you also get what they give you, which is the 2/3. So, ta-da! Okay, now we're going to get into some of these application problems. So you're going to find the 6 trig ratios for the angle formed by the x-axis and the line that passes through the origin and the point 3, 6. So ask yourself where this point exactly is in the coordinate grid. So 3, 6, it's positive, positive, which means we're going to be in quadrant 1. So what's going to happen, I'm going to draw just quadrant 1. I don't need the other quadrants, just quadrant 1. And then I'm going to draw a triangle. And then this triangle, this point right here, is going to be 3, 6. So remember, your 3, 6, this is going to be your x and your y. So your horizontal component of this triangle is going to be 3. The vertical component of your triangle is going to be 6. And then this is going to be a right triangle. So we have some angle that's formed with the line that passes through 3, 6 and the x-axis. So this angle is what we're really focusing on. So first thing I need to do is I need to find the value of my hypotenuse. So I want to find, I'm just going to say this is n, because I believe if we use x, it's going to be something else. Actually, we could use x. I mean, the letter doesn't really matter. So when I do Pythagorean theorem, so 3 squared plus 6 squared is going to equal x squared. So that's going to be 9 plus 36 is going to equal x squared. So that's going to be the square root of 45. And then when you simplify 45, so this can branch into 3 and 15. Then 15 branches to 3 and 5. I have a pair of 3's and a leftover 5. So this is 3 root 5. So now that I have all 3 of the sides of my triangle, now I can go ahead and do my trig ratios. So I know sine of theta. So that's going to be the opposite over the hypotenuse. So 6 over 3 root 5. And of course, we need to rationalize. So I'm going to multiply by root 5 over root 5. So when I rationalize, that's going to give me 6 root 5 over 3 times 5, which is going to give me 6 root 5 over 15, which is going to simplify by a factor of 3. So that's going to give me 2 root 5 over 5. Now for cosine theta, so I want the adjacent over the hypotenuse, so the adjacent over the hypotenuse. So that's going to be 3 over 3 root 5. So I'm going to simplify first. So my 3's are going to simplify, so I'm left with 1 over the square root of 5. And then I'm going to rationalize. So I'm going to multiply by root 5 over root 5. So when you simplify, we're going to have root 5 over 5. So now for a tangent theta, so I want the opposite over the adjacent. So opposite, which is 6, over the adjacent, which is 3. So we have 6 over 3, which that's just going to simplify to 2, which isn't that nice. Okay, so now I have the big 3. Now I want to do the reciprocal ratios. So I want to do cosecant of theta. So you can either flip the original or the simplified. So typically it's going to be the original. So I'm going to flip, and we're going to have 3 root 5 over 6, which is going to simplify to root 5 over 2. Okay, and then with secant theta, so once again, I'm going to flip the simplified original. So that's just going to be root 5. Okay, and then with cotangent, flip 2, and you get 1/2. That was easy. So there's kind of a mock one for you. I would say go ahead and try number 10, or pause here, try number 10. It's the same idea, and then I'll go through that one. Not number 10, hello? I can't read today. Okay, so 14, I mean. So find the 6 trig ratios for the angle formed by the x-axis and the line that passes through the origin and the point 5, 2. 5, -2. Reading is hard, y'all. Okay, so 5, -2. So this is going to put us in quadrant 4. So when I draw quadrant 4, I'm only going to draw what I need. Okay, so now that I have this, so we're going to pass through the point 5, -2. Okay, so my angle is going to be between the x-axis and the line that passes through 5, -2. And then you're going to look at the components. So 5 is my horizontal component, and then -2 is my vertical component. So I need to find the hypotenuse. So I'm going to do Pythagorean theorem. So 5 squared plus -2 squared is going to equal x squared. So 25 plus 4 is going to equal x squared. So your hypotenuse, in this case, is going to represent the square root of 29. Gross. All right, so now I'm ready to do my trig ratios. So sine of theta. So that's going to be the opposite over the hypotenuse. So -2 over root 29. And then you're going to rationalize. So I'm going to multiply by root 29 over root 29. So this is going to give me -2 root 29 all over 29. So gross, but it works. Okay, now same idea for cosine. So cosine theta is going to be the adjacent over the hypotenuse, so 5 over root 29. And then once again, we're going to rationalize. So that's going to give you 5 root 29 over 29. And then tangent theta. So that's going to be the opposite over the adjacent, which is just -2/5. And then I want to do the reciprocal ratios. So I'm going to start with cosecant, which is the reciprocal ratio for sine. So based on the original setup, I'm going to have -root 29 over 2. I'm just going to move the negative to the top. And then for secant theta, we're going to flip the original, so that's going to be root 29 over 5. And then for cotangent of theta, it's going to be -5/2. Ta-da! Okay, and then the rest of these on this page are going to be kind of just renditions of what I just did. And then we're going to have some word problems down here that deal with trig ratios. So the one that I want to focus on is going to be 21. So with 21, so while taking a ride in the hot air balloon, Taylor wonders how high up she is. To find out, she chooses a landmark that's to the east of the balloon and measures the angle of depression to be 54 degrees. So a few minutes later, after traveling 100 feet east, the angle of depression to the same landmark is 61 degrees. So how high up is the hot air balloon from the ground? So starting off, we give you a lot of information that you need to kind of break down. So very small but important information that we give you is that there is a landmark to the east. That's going to tell you kind of the direction that this person's traveling, and that's going to tell you how to set up this picture. So this person is going to be up in the air, and then I'm going to draw some horizontal distance. She's traveling eastward, so then from the ground, then this is going to form a 90-degree angle. So where she currently is, we're going to say first sighting is over here. The angle of depression at first is going to be 54 degrees. And this is at the first sighting. I can't draw. And then it says that she's going to travel 100 feet east. So about 100 feet later, so doesn't have to be to scale, she's going to see the same landmark, and then that angle of depression is 61 degrees. Now, emphasis on the fact that here she traveled 100 feet. And then they want to know how high up the balloon is. So I want to know this height. So the landmark would be down here. So from here, what we're going to be looking at is we're going to be looking at this smaller triangle here, but then we're also going to reference this larger triangle here. We're going to use both of these triangles to set up trig ratios, and then what we're going to do is we're going to set up systems. Whoops, this is the second sighting. So for the smaller figure here, or the smaller triangle, so let's kind of look at it in blue. So based on the angle, we have the opposite, which is the height, and then that's it. So we don't know what this distance is right here. So I'm going to say this is just going to be a distance of x. Okay, and then if I look at the bigger triangle, which I'm going to say in purple right here, we know opposite is the h value, and then the adjacent, which is the full length, is going to be 100 feet plus x, which I'm going to write as x plus 100. And that's going to be this full horizontal length. Whoops, I missed. Close enough. So what I'm going to do is I'm going to first look at the quote-unquote small triangle. So the small triangle is the angle depression that has 61. So if I have the opposite and the adjacent, I can use tangent. So I know tangent of 61 is going to equal h over x. And then I'm going to reference the larger triangle. So the larger triangle, once again, we're going to be using 54 degrees. So opposite of 54 is going to be h over the adjacent, which is the full length, which is going to be x plus 100. So tangent 54 is going to equal the opposite, which is my h value, over the adjacent, which we know is x plus 100. Now, I want to know what the height is. So what I want to do is I want to solve both of these equations for the height. So if I solve the left equation over here for the height, multiply both sides by x. So we're going to get the height is equal to x times tangent 61. And then on the right side, I'm going to multiply by x plus 100 on both sides. So I'm going to get h is equal to x plus 100 times tangent 54. Now, you can do this step now, or you can do it later. I'm going to go ahead and just do it now. Notice how the x plus 100 is in parentheses. So technically, we are going to have to distribute. So when I distribute, so we're going to get x times tangent 54, and then plus, my handwriting is so bad, plus 100 times tangent 54. So we know the height is going to be representative of both of these values. So if you think back to your geometry days, now what I'm going to do is the reflexive property, where I know the height is going to equal its height. So I'm going to pull the height from the small triangle and then the height from the big triangle. These values have to be equal. So on the left side, I'm going to have x times tangent of 61, and then that's going to equal the height of the larger triangle, quote unquote, even though they have the same height, which is x times tangent 54 plus 100 times tangent 54. And then what we want to do is now we're going to set up this equation and we want to solve it for my x value. But notice how your x value is in two different places. So what I'm going to do is I'm going to subtract x tangent 54 on both sides so that I can get my x value on both sides. So doing this, writing crooked. So this is going to be x tangent 61 minus x tangent 54, and then that's going to be equal to 100 tangent 54. And now if you look on the left side, we have x in both terms. I'm going to factor out that x value. So when I factor out the x value, we have x times tangent 61 minus tangent 54, and then that's going to be equal to 100 times tangent 54. Now, if I want to solve for the x value, now I'm going to divide both sides by tangent 61 minus tangent 54. So I know it's hard to realize, maybe you can hear it, but hopefully you notice I haven't even touched my calculator yet. So I'm strictly doing all these steps by hand for right now. We're not going to use the calculator until the very end. So my x value in exact form is going to be 100 tangent 54 over tangent 61 minus tangent 54. So I'm still not even going to grab my calculator, because if I were to type that in, that gives you the x value. That gives you this horizontal length. What we want to know is the height. So what I'm going to do is, if I know my x value is equal to this monstrosity, just like systems, when you get one value, then you're going to plug it into your original equation, one of your original equations, and you can solve for the height. Now, we have two equations that we could work with. We have the small triangle, or we have the large triangle. My advice is work with the one that has the fewer terms and that's easier to work with. So I'm going to reference h is equal to x times tangent 61. So if I know the height is equal to x times tangent, I already forgot, 61, then what's going to happen is I'm just going to take this x value and I'm going to sub it in right there. So I use the storage feature on this step, but you don't have to. So, or really if you want to just plug it in directly how it looks. So 100 tangent 54 over tangent 61 minus tangent 54. And then that's going to be all times tangent 61. And that's going to give you a height of 580.607 feet. Ta-da!